Hello everyone, this is Sanjay from CSIT branch. Today, my AAT Tech Talk topic of human-computer interaction is the design and implementation of Arrow game projection interactive system based on deep learning. So before directly jumping into the topic, we know about deep learning. Deep learning is a subset of the machine learning methods which are based on artificial neural networks with representation learning. The objective in deep learning refers to the use of multiple layers in the networks. So, with the rapid development of projection technology, the implementation and study of projection interactive system with rapid scenarios has made great progress. Humans are no longer just satisfied with the traditional way of interacting with computers through peripheral devices, but are eager to obtain a more natural, friendly mode of interaction. Thus, an Arrow game projection interactive system based on deep learning is designed and implemented in this way. Firstly, an Arrow game scene includes variety of vivid interfaces is developed by Unity 3D in order to improve user experience. Secondly, a method of mapping the position of arrow in the captured image to the corresponding position of game scene is achieved. Thirdly, object recognition is realized by using the target detection algorithm based on. Finally, the experiment result demonstrate that the novel pattern of interactive system has good real-time performance and high robustness. Designing and implementing an Arrow game projection interactive system based on deep learning involves combining computer visions, machine learning, and interactive technologies to create a system that can track and respond to the user gestures in real time. Here is a step-by-step guide to design and implementing such a system. So now we are going to define objectives and requirements of this game. The first outline the objectives for the Arrow game projections. The specify the requirements includes hardware like the projectors and cameras, and software deep learning frameworks, game engine, and desired user interactions. Select technologies and tools. Choose a deep learning framework suitable for your application. Like example, we can use TensorFlow and or PyTorch and select a game development platform or engine. Like there are many types of game development platforms like Unity, Unreal Engine, so we can use any of them for creating the interactive game. And the third one is data collection and annotation. Gather the data set of the images or videos featuring users making arrow related gestures. Annotate the dataset to label the key points or regions of interest corresponding to arrow gestures. Deep learning model design. Design a deep learning model for pose estimation or gesture recognition. Popular architectures include convolutional neural networks and recurrent neural networks for sequential data. Training the model. Split the annotated dataset into training and validation sets. Train the deep learning model using the training set and validate its performance on the validation set. And fine tune the model for better accuracy. Integration with game engine. Integrate the trained model with the selected game engine. Implement a communication interface between the deep learning model and the game logic. Real-time gestures recognition. Set up real-time video input from camera. Implement the inference pipeline to process video frames and recognize arrow gestures in real time. And the game logic implementation. Develop the game logic considering how arrow gestures will control the game. Implement scoring mechanisms, levels, and any other game-related features. Projection and display setup. Configure the projection system to display the game in the desired environment. Ensure proper alignment and calibration for accurate gesture tracking. User interaction design. Design initiative user interactions and feedback mechanisms. Consider providing visual or audio cues to guide users during the arrow gestures interaction. For the testing and optimization, test the Arrow Game Projection interactive system with different users and scenarios. Optimize the deep learning model and game performance based on user feedback and system metrics. Deployment. Prepare the system for deployment in the target environment. Ensure documentation and support mechanisms are in place. The user experience enhancement. Continuously gather user feedback to improve the system responsiveness and overall user experience. Consider updates and enhancements based on user suggestions and emerging technologies. AR. It is also known as augmented reality, a new technology that seamlessly integrates the real-world information and the virtual world information, enables users to interact with virtual scene naturally. Nowadays, it has developed swiftly thanks to mature virtual reality image processing and pattern recognition techniques. The development of increasing complicated image processing technology and computer vision techniques, the research and applications of projection human-computer interactive system based on camera projections have become more and more diverse. In 2002, Jun Rikimoto in Tokyo designed a new method of locating the position of targets with the assistance of an infrared generator, which emitted a layer of infrared light to the projection plane. When the user's body or object blocked the infrared light, the image captured by the camera produced the bright spot with which it was able to find the precise position of targets quickly. However, because of the infrared components in the natural light, the system was suspectably disturbed by ambient light, thus must be shielded from natural light in the process of use, and the accuracy was also easily affected by the flatness of the projection plane. In 2004, Kim in Germany proposed an effective method of avoiding the changing light emitted by the projector from affecting the capture of gestures. So, the design of Arrow Game Projection Interactive System based on deep learning. In our passage, the hardware composition of the Arrow Game Projection Interactive System based on deep learning just consists of a projector, a USB camera, and a PC. The projector that connects the PC by HDMI interface projects the PC screen images onto the wall, and the camera that connects the PC by USB interface capture images in the real time, which will be sent to the PC or image processing and target positioning. What's more, the projector and camera are facing in the same direction. The entire hardware structural design of the system is shown in the figure. So in the given figure, we can see that how the setup has been placed, and it is the hardware structural design of the interactive system. Because users' experience is an important evaluation standard of the human-computer interactive system. Several kinds of game scenes such as grass shooting target, forest shooting monster, show shooting snowman and mountain shooting prey are developed by Unity 3D, a 3D game development engine. So the real flying arrows and vivid game objects in 3D scenarios all create an immersive experience for the user. In some degree, these unique animation scenes strongly enhanced the user's interest and satisfaction in using the projection interactive system. Diversified game scenarios based on Unity 3D. Firstly, in order to form different kinds of game scenarios, it is of necessity to import or design these resources bundles such as snow, forest, mountain, grass, sky, monster, and archery target formed by firings. Secondly, the collision response function is developed for the purpose of defining corresponding actions when arrow hits the target in the projection plane. Thirdly, a progress bar is realized to adjust to difficulty of game by increasing or decreasing the response area. Finally, gain arrow coordinates from text in a certain period generate a virtual arrow in Unity 3D software and then simulate the next flight trajectory The game interfaces are given in the figure. In the given figures, we can see how the game interfaces like snow shooting, snowmen, and the forest shooting, and the mountain shooting, and the grass shooting are shown here. The next we are going to see how arrow position mapping to the corresponding games in position. Due to distortion of projector lenses, the projector image is not exactly the same as what PC screen displays as shown in the figure. ABCD represents the projection picture of the interaction plane and point to expresses the arrow position ABCD, which are corresponding points of ABCD, which means four vertices of PC screen image respectively. Moreover, WH indicates the width and height of the resolution of the PC monitor respectively. O means the position of the mouse pointer, and O with the coordinates of x and y should be mapped to the O, x naught and y naught in the interactive system in order to control the arrow movement in the software. And the figure shows the arrow position in the projection image, and the right picture shows the mapping to the corresponding games in position in the PC screen. So finally, I conclude on the topic is that an innovation arrow game projection interactive system based on deep learning is put forward in our passage. The first part of human-computer interactive system is several vivid game scenarios designed by Unity 3D to improve user interaction experience. The second part is method of mapping the arrow position in the captured image to the corresponding position of game scenes based on Hall line detection and linear interpolation, which greatly ensures the proper conduct of the interactive process. The third part is the improved target recognition algorithm developed to capture the position of arrow fastly and precisely, which guarantees the continuity of arrow flight. Compared with those systems based on infrared generator or specific auxiliary or projection, interactive system puts aside the shackles of equipment and enhance the intelligence of interaction. Moreover, thanks to the deep learning algorithm for object detection, our system solves the problem of human-computer interactive system being susceptible of the environment affected by the flatness of the projection plane. And in this figure, we can see how the game projection interactive system works. In the picture, we can see a projector is projecting the target on the wall, and a human being is trying to interact with the system through the arrow. So these are my references of the given topic. There are differences. Thank you.